guy did that I've referenced down at the bottom here, called Dave Eitel, is he took that bug, he changed it so that it was reliable on more recent versions of Internet Explorer 7 and 8, and then paired that with one of the kernel bugs we talked about on the previous slide to break out of the sandbox, and therefore turn that bug into something very serious, even on completely patched, very recent versions of the operating systems we use daily. So, just to do a time check, I think that's the end of what I wanted to talk about. Hopefully it wasn't too much of a divergence from the usual OWASP material, but this is the stuff that scares me and keeps me up at night, and if you want to talk about it, I'll be around at the conference, and I'd love to talk to you.
Thanks, Chris. So I think Chris gave you an idea that exploits and vulnerabilities do exist, and while we are doing a lot of work to sandbox more and more of the browser environment, there's still going to be 0 days, there's still going to be bugs in these sandboxes. So how do we protect users against these 0 days? How do we have more defense in depth mechanisms? I'd like to talk a little bit for what I call beyond the sandboxing. You know, sandboxing is certainly something that we're very excited about. It's great work. It's something that we need, and we're very happy to see. But it's not in and of itself sufficient. The sandboxes are written by humans, and there are going to be bugs in the sandbox that can be exploited. There's also what I call user bugs. Users are not perfect. If we do all the work to sandbox the browser, the plugins, we make sure that the computing environment is safe, there's still going to be sites that tell a user, go download this file so that you can view your porn in higher quality. And the user is going to say, yes, I want higher quality porn, and install some virus. So we can protect the system, but we also have to think about protecting the user from social engineering attacks. And as Chris sort of got into at the end of his talk, there are more attack surfaces being exposed by new APIs in the browser. So all of these are going to create gaps in the security environment that blacklisting can help us in terms of providing additional protection for users. I'd like to sort of point out that we view blacklisting as a defense in depth mechanism. It is not our only story for security, nor should it be. Blacklisting is great because it can help us mitigate against 0-day risks. So as soon as we find out a bug, we're going to work on creating a patch, but it does take time. It also takes time to get users to update their software, as Chris showed. Blacklisting can help us react to these 0-day threats very quickly. It can also help us protect users against threats that are not as easy to handle in software, things like phishing attacks and social engineering attacks. So in terms of what this actually looks like, we first rolled this out in Google search results, I think maybe 4 years ago, where in a list of results, you'll see underneath a particular site a label that says this site may harm your computer. And if you click on that label or on the name of the site itself, you get taken to an interstitial page. To motivate why this is important, this is sort of a contrived example. This is real. If you search for my name, you do see the site up there. I own it. I'm aware of it. This actually comes up in a lot of searches. Somewhere, it varies over time as we get better in ranking and demoting spam results. But given the particular day of the year, anywhere between 0.5% and 1.5% of search results actually result in a click to a malicious site. So this is something that is a very real threat. It's not just, user navigates to a shady porn site and downloads a codec. You see a lot of high-value, high-traffic sites, things like news sites, government websites, also advertising exchanges. Lots of users, lots of potential for damage here. So how do you measure the success of a blacklist approach? We know we're not going to cover everything. There's 3 main metrics that we need to look at. The first one is the freshness of data. Obviously we have to find out about the attack, and we have to get that information to users. How long is that time delay? The second is coverage. There are a number of attacks out there. We're not going to cover all of them. I take that back. There was one day where we did have 100% coverage. Back in January of 2009, we successfully protected users of Google Search against every single threat on the internet by giving them an interstitial. Sadly, we gave this interstitial on every single search that you did, so while we had 100% coverage, our accuracy was nowhere near 100%. So accuracy turns out to be important as well. If you tell a user everything is bad, they just ignore whatever you say. So we need to make sure that we have a low rate of false positives. So how do we actually build up this blacklist? Well, the first part is URL discovery. This is slightly different for phishing and malware, but the first thing that you have to do for both of these attacks is you have to find where the attacks are actually living. You have to find all of the URLs that your users are going to visit that are going to exploit them. This actually turns out to be a hard problem. Once you have this set of URLs, not just the bad URLs, but also the good URLs that you need to filter through, you need to do some classification. So you need to say, is this URL actually going to harm my user or not? In terms of once you have that list, you need to get it out to users. So over the past few years, we've worked on providing an API where we make all this data available, not just to Google search users, but to users of multiple browsers, including Chrome, Firefox, Safari. I believe Opera uses the data as well. So that's hundreds of millions of users right there that you have to deliver a list of approximately 500,000 URLs to. So if you think of 500,000 times the size of a URL, we actually hash it, so 500,000 times the size of a hash, times hundreds of millions of users, times an update every half hour. It's actually a non-trivial problem. It's a lot of bandwidth, a lot of computational resources. So actually distributing the blacklist turns out to be a hard problem in and of itself. And then we have to think about the scope. You know, there's phishing attacks, there's malware attacks, but we're also seeing a lot of social engineering attacks. So not just drive-by downloads, but you go to a site and it says, you know, you should install an antivirus program. Here's an antivirus program, install it. And the antivirus program is itself actually a virus. And we're seeing a lot of these charge money. So it'll say, you know, it's on sale now, $29.99 for a great antivirus program. The user will actually pay to get exploited. I find this really, really both cool and disturbing. So again, the approach varies for phishing and malware. Let's look first at phishing. If you're in Chrome or most other browsers that we give data to, you get a warning that looks something like this when you go to a phishing page. So it says pretty clearly, it's been reported as a phishing site. It briefly explains what phishing is and gives you an option to proceed anyways or go back to safety. I'd like to get a quick show of hands for how many of you think users click through this warning. So how many people out there think that less than 1% of users click through this warning? Sorry, let me reverse that. How many of you think that more than 1% of users click through this warning? All right, more than 5%. More than 10%? More than 25%? More than 50%? Okay, I see a lot of hands going down, but there's still some up. I think a lot of us in the security area think that if we warn the user, we have somehow absolved ourselves of responsibility. You know, we say, well, we told the user it was a bad idea, they shouldn't go there. That's all we can do. We've done our part. We have statistics on how many users click through the phishing and malware warnings. Unfortunately, they're lumped together. But last time I looked, which was a few weeks ago, it's actually about 50% of the users clicking through this warning, just under 50%. So, you know, yes, we are doing great work. We are finding a lot of attacks, but if the users are clicking through it, clearly there's a problem, and clearly it's not sufficient in and of itself. But how does this actually work? So, you know, is it still important? Yes, it's still important. As Chris said, we are hardening the browser environment. We're hardening the browser sandbox. So attackers are going to continue to turn more and more to trying to attack the user, trying to get them to disclose their personal information, be that passwords. It's a lot easier than trying to compromise the computer. You know, I can just ask the user for their password and they'll give it to me. So why should I try to figure out how to take it if they'll just give it to me? So how do we find these phishing attacks? Where does the data come from? For phishing, we use a combination of user submissions as well as looking at spam that comes into Gmail. So it turns out that we have a lot of Gmail users that get a lot of spam. There's a lot of phishing attacks included in that. So we go from millions of URLs that we think are spammy, but we don't want to send out every single spam URL to all the browsers. We don't want to say, warning, you're about to go to a spam site. It's just too much data. So we have a machine learning process that takes all these URLs and returns the prediction of how likely that is to be phishing. And if it's above some threshold, then it's automatically added to a blacklist. If it's in sort of a marginal range, we have human reviewers take a look at it. There's a lot of academic research going on here, new features to look at in terms of classification, as well as things like visual similarity. So actually taking the rendered image of the web page and comparing that to other known phishing web pages. And if it's similar to another phishing web page, then it's probably phishing in and of itself. Obviously, there's some caveats that the real site looks similar to a phishing site, so you have to be a bit careful. So we're using this to go from millions of URLs to, at any given time, I think there's around 250,000 sites on our phishing list right now. Malware is a bit different. It requires a bit more skill to know how to exploit the browser than to exploit the user. But it's still worth it. If you have a 0-day in a browser or in a popular plugin, you can get incredible reach. Whereas with a phishing attack, you have to actually send out email and get people to come to your site. With a malware attack, you can just pay to get users. You can take out an ad in an advertising network, and all of a sudden you have hundreds of millions of users seeing your ad, getting exploited, and the value of the exploited user is more than you paid to put out the ad, so it's still an income-generating enterprise for you, the attacker. So how does this work for malware? How do we discover these attacks? Well, the URL discovery part is a bit different in that people are compromising popular websites. They're not setting up new websites and directing users to these new websites. They're taking something like news websites, government websites, places that people are already going, that already have high traffic, and compromising those. So we start with basically our copy of the internet, our index. We apply machine learning techniques to all the URLs in the index, trying to figure out, are they likely to be malicious? Are they worth further investigation? And for those URLs that are worth further investigation, we actually load them up in a virtual machine. So we start up a virtual machine. This is all automated, of course. Start up a virtual machine, browse to that site in a browser, and see what happens. For most websites, there should be very few side effects. Some things might get written into the cache, your history might get updated, but you shouldn't see files being written to C Windows System 32. You shouldn't see new processes starting. You shouldn't see registry settings change. So it's actually very easy for us to see when a virtual machine is compromised for malware. So we have very high confidence when we add something to our malware list that this is actually a real attack and not just a false positive. So where will the next 0 days lie? I think it's important to look at a lot of the new APIs that are being exposed, not just by plugins, but actually by the browsers themselves. So in HTML5 and contemporary APIs, we, the browser, are making it our mission to say that a web application should be able to do anything that a desktop application can do. So that means exposing a lot of functionality that, from a security perspective, is quite scary. We're exposing new APIs around 3D graphics. So you basically have OpenGL support from JavaScript. This means that you can run shader programs, which are bytecode that runs on your CPU, and you can do essentially computation on the GPU. You can blue screen the computer on most drivers because there's bugs. We're exposing things like file system APIs. So now we'll take whatever files that you want us to save, and we'll actually save them off on a folder in the user's file system. Think sort of like a CH root under the user's profile directory. But again, if you can get creative with file names, maybe you can exploit that. And as Chris mentioned earlier, we'll now let you specify a font, and that font can contain bytecode to specify how the font hinting should work. So that bytecode gets executed by the OS. So again, we're taking a lot of drivers and a lot of